Hey guys, my name is Devin, my YouTube channel is DRG Bros. Today we are going to be talking about some equations in quadratic form. So if you remember from our last video, given the equation ax squared plus bx plus c for any polynomial in standard form, we can find our x by using our quadratic formula, which we proved in our last video. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So basically, x can be solved based off of the coefficients. So using this knowledge, can we solve higher degree polynomials? Such as maybe ax cubed plus bx squared plus cx plus d? Well, the answer is yes. Now, we're going to cover that in a later video, but for today, I would like to look at some special cases between the two. So, our first special case that we're going to be doing is going to be x to the fourth minus 5x squared plus 6. So what we're going to do some change of variable here. And we're going to let a, like capital A be equal to x squared. And then, so the first thing that we're going to do is we're going to pull all the x squareds out of this so that we have something to turn into. So we have x squared squared minus 5 parentheses x squared plus 6 equals 0. And now we just replace them with a. So now a squared minus 5a equals 6. Or plus 6 equals 0, sorry. Which then we can solve like any normal polynomial. So we have a minus 3 and a minus 2 equals 0. And then now we start, we gotta solve it a little bit more first. We split it. A minus 3 equals 0, or a minus 2 equals 0. So then a is equal to 3, or a is equal to 2. So now if we plug back in a from the very beginning of the video, we have x squared equals 3, or x squared equals 2. That leaves us with and then we square root everything. Square root of x squared equals the square root of 3, or the square root of x squared equals the square root of 2, or plus or minus the square root of 3 and plus or minus the square root of 2. I'm so sorry about that. And so x equals the square root of 3, square root of 2, minus the square root of 3, and minus the square root of 2. So our next example is pretty much just as simple, I guess. It's just slightly different. So we're going to be doing x to the 6th minus 7x to the 3rd plus 10 equals 0. So we're going to do the same thing. We're going to let a equal x cubed. So then we have x cubed squared minus 7x cubed plus 10 equals 0. A squared minus 7a plus 10 equals 0. And we just go through this whole process, which I've shown in a couple different videos. So if you really want to know how to do this, then go check that out. I don't want to explain it here because that's not what we're focusing on at the moment. So then a equals 2, or a equals 5. So now we replace that, so x cubed equals 2, or x cubed equals 5. So since it's cubed, we don't use the plus or minus. So it's the cube root of x cubed equals the cube root of 2, or the cube root of x cubed equals the cube root of 5. So now we did the cube root, and so I have x equals the cube root of 2 and the cube root of 5. Now, according to according to the fundamental theory of algebra, there should be 6 solutions to this polynomial, but I only have 2. Now, the reason that is, I'll go over how to find the other 4 solutions in a later video, but it's a little too complicated to talk about here. I'll review it later, don't worry about it. I'll show you how to do it eventually, but for now, these are the 2 simplest answers. Alright? Moving on to our third example. We're going to have x plus the square root of x plus 6, or minus 6, sorry, equals 0. So what are we going to do here? So we're going to let a equal the square root of x, so that a squared equals x, and then we can replace them. We have a squared plus a minus 6 equals 0. Do the solvey thingy. A plus 3, a minus 2 equals 0. So a plus 3 equals 0, or a minus 2 equals 0. So then a equals negative 3, or a equals 2. So now we have the square root of x equals negative 3, or the square root of x equals 2. So we're going to square both sides, and we have x equals 9, or x equals 4. But here's what I'm going to say about this. The coefficient of this first number, like you saw how in our previous example, it had 6. Well, basically, that's the number of solutions it has. So this only has 1 solution. And as you'll find, if you try to solve it, only x equals 4 works. X equals 9 actually doesn't work. In fact, that amounts to a solution of 6 instead of 0. Well, x equals 4 does, in fact, equal 0. So, you can get false solutions. Somewhere along the line, it just gives you, like, these separate solutions. Alright, we only got one more example now. Example number 4. We're going to be doing a little something different. So, this one's going to be the most complicated one. So, we're going to have x plus 1 to the 6th power plus x plus 1 to the cubed minus 72 equals 0. So what we're going to do is we're going to let a equal x plus 1 and b equal a cubed. Now why would I do that? Well, let me show you. So first we're going to replace all the x plus 1s with a's. So we have a to the 6th plus a cubed minus 72 equals 0. Then we replace the a cubes with b, so now we have b squared plus b minus 72, putting us in standard form. So then we have b plus 9, b minus 8 equals 0, b minus 9 equals 0, or b minus 8 equals 0, or b plus 9 equals 0. So then b equals negative 9, or b equals 8. Now we replace it back, so then we have a cubed equals negative 9, or a cubed equals 8. Cube root everything. Or the cube root of a cubed equals the cube root of 8. Okay. So now for now we're going to just ignore the cube root of negative 9. So now we're going to swap to the x plus 1. So now we have x plus 1 equals the cube root of negative 9, or x plus 1 equals 2. So x is equal to 1. And again, there are 5 other solutions, but this is the easiest one. Thank you guys very much for watching this video. I hope you enjoyed. Please go check out some of our other videos and like and subscribe. Bye, guys.